Okay, the first part of today, we're going to talk about long division and synthetic division. Tomorrow, we're going to talk about something called the fundamental theorem of algebra, and we're going to talk about something called P over Q. It's really quite simple, I promise. But today's going to be a little bit of a review from like third grade. Some of you may have gotten this last year at Algebra 2. Some of you may have missed it, depending on who you had and how all that worked. But do you guys remember, like, say you had to divide 3 into 197, right? How do we do long division? 3 goes into 1. Doesn't go into 1, right? So 3 goes into 19. How many times? 6. So we write it right above the 9 where we're going into. So then we multiply, correct? 3 times 6 is 18. And at this point, what do? Subtract. So 19 minus 18 is 1. And then what do we do with the 7? We bring it down. So then we start again. We say, okay, 3 goes into 17. How many times? 5. Okay. And then we multiply. 5 times 3 is 15. 17, we subtract. 17 minus 15 is 2. And what is 2? It's our remainder. So you would take the 2 and you would put it over the 3 that you divided by, right? 2 over 3. So your answer would be 65 and 2 over 3. It's your remainder, your leftover. Everybody remember that? We're going to do the exact same thing now, but we're just going to divide polynomials. All right? Again, you might have seen this last year. You may not have. So I'm going to show you what I think is a pretty foolproof way to do this. It's not the easiest thing in the world. You guys are going to be like, oh my gosh, this is horrible. I get it. But there is going to be one on your quiz that says you have to divide using long division. So if you can check it using synthetic, which we're going to talk about in a minute, that's fine. But I need you to actually demonstrate that you know how to do this. So this says divide the polynomial, blah, 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 by x minus 2. So whatever you're dividing by is going to go on the outside. Whatever you're dividing into goes on the inside. So I have 6x cubed minus 19x squared plus 16x minus 4. Now the first thing to look for, guys, is when you're dividing, whether it's long division or synthetic, is you have to make sure there's no gaps, there's no holes. Meaning, what is the highest exponent that's inside my division problem? X cubed. So there needs to be a placeholder for everything behind that. There needs to be something for x squared. There needs to be something for x. There needs to be something for the constant. If there isn't one, what do we put? A 0, okay? You have to have the placeholder. In this case, we have x cubed, x squared, x to the first, constant. We're good. So this is how we're going to attack. Follow along with me. I'm going to go nice and slow. This is how we're going to attack long division. You say first term into first term. So I always do a little side work over here. I say x times what gives me 6x cubed. X times what would give me 6x cubed? 6x squared. So look where I'm going to write 6x squared. I'm writing it above my x squared. I like to keep everything organized. This will help you, I promise. So when we did our division, we said, okay, 3 went into 19. How many times? We wrote it. Then what do I do at this point? What did we do up here? 3 went into 19 6 times. Then what did I do with 6 and 3? No, we didn't subtract. We said 6 times 3 was 18. So we're going to multiply here. I'm going to multiply 6x times x is what? 6x cubed. And then I'm going to say 6x times negative 2, and I get negative 12x squared. Now notice, guys, I put that in parentheses because this next step I have to subtract. If you miss this step, this is going to mess everything up. And we're going to do a couple of these just to kind of get your practice. But when you are subtracting polynomials, right, this says 6x cubed minus 19x squared minus 6x cubed minus 12x squared. What do I have to do with that subtraction sign? Distribute it. At this point, every time I'm going to tell you to change this sign here and then change the stuff in the middle. And now you can combine. That's a bad color choice. What is negative 19 plus 12? What kind of 7x squared? Hold on, let's just follow along, and then if this is a process, it's going to go a bunch of times. Negative 7x squared, good. What happens with my 6x cubed minus 6x cubed? It cancels, and then what do I do with positive 16x? Bring it down, and we're going to do the process all over again. It's always going to be first term, x, into this first term. So let's do a little side work. X times what gives me negative 7x squared? Negative 7x. So look, I'm going to put it right here above the 16x. I keep my variables set. Now, before I multiply, I'm going to get my subtraction set up so I don't forget to distribute the negative. Yes, ma'am? You're subtracting, but since we're subtracting polynomials, you have to distribute this minus sign. So what it does is it changes this, and then it changes all the signs behind it. I always recommend when it's the subtraction part, I put my parentheses and my minus sign so I remember, ooh, I got to change all the signs. So now we're going to multiply, and we're going to say negative 7x times x is negative 7x squared. And then what's negative 7x and a negative 2? Positive 14x. Before I can subtract, what do I have to do to that division, that subtraction sign? I have to distribute. So this is going to change, change, change. It changes all of the signs. When you distribute that negative, you're changing that first negative to a positive, and then it changes all the signs. So just remember at that step, change, change, change. And now we combine. What's 16x minus 14x? 2x. What happens with a negative 7x squared and a positive 7x squared? It cancels. And then what do I do with minus 4? You bring it down. And we're going to do the same thing all over again. It's always first term, whatever you're dividing by. So first term into first term. So x times what gives me 2x? 2. Positive, right? So plus 2. Get your subtraction set up before you multiply. So we multiply. What's 2 times x? 2x, good. What's 2 times negative 2? Minus 4. Before I subtract, what do I do with that minus sign? So I change, change, change. What's negative 4 plus 4? 0. What's 2x minus 2x? 0. And there we're done. Do I have anything left over? Do I have any remainder? No. So what you guys just showed me, that when you divide 6x cubed minus 19x squared plus 16x minus 4 by x minus 2, your answer is 6x squared minus 7x plus 2. We're going to do a bunch of these. That's why I wanted to do everything yesterday that we did so we could get this done today so we have a little extra time to practice. We'll be able to practice a little more tomorrow. We'll practice on Thursday. And I'm going to show you the shortcut to this, but you are going to have to do long division one time. But I will show you the shortcut that you're probably never going to do this again. All right, let's start. I got 2 more to do here. Let's do number 3 first. 2 is a little harder. Let's do number 3 first. What's going on the inside? What's going on the outside? Perfect. 2x plus 3 is on the outside. Stay nice and organized. And then what goes on the inside? 2x squared minus 17x minus 38. So make sure there's no gaps, right? So I write down 2x squared. Do I have something that's going to stand in the x to the first power? Yep. So minus 17x. And then I have a constant. So again, we're going to do the same process every single time. Remember, first term into first term. So 2x times what gives me 2x squared? X. So watch, I'm going to put it right here above my 17x. I just like to keep everything organized. Before I multiply, I'd like to get my subtraction set up. So I'm going to multiply my x to each term. So I have x times 2x is 2x squared. Perfect. Do it black. And then I have x times 3 is perfect. Now, before, guys, every single time, before you subtract, what do I have to do with that negative sign? Distribute. So change, change, change. Y'all are more than welcome to use my color pencils anytime you need to. So now when we combine, what's negative 17x minus 3x? Perfect, negative 20x. What happens to my 2x squareds? They cancel. And then what happens with minus 38? We bring it down. Perfect. And we're going to do the same thing. First term into first term. So 2x times what gives me negative 20x? Negative 10. So minus 10. Get your subtraction set up before you multiply. So I have, okay, negative 10 times 2x is negative 20x, good. And then negative 10 and positive 3 is minus 30. Look, guys, if you forget to distribute, when you combine, what's negative 20 and a negative 20? Negative 40, right? So that's why you have to distribute this negative. Change, change, change. You have to do that first or else your problem is wrong. So negative 38 plus 30 gives me negative 8. And what happens with my 20x's? They cancel. Is there anything left to bring down? No. So what is negative 8? Your remainder. So just like we did when we had 2 left over, we put it over, we divided by the 3, right? So this becomes x minus 10. What kind of an 8 is that? It's negative, so it becomes x minus 10 minus 8 over, what do we divide by? 2x plus 3. Perfect. Now, these problems can get messy in a hurry. I understand that. So what you guys, honestly, what I would tell you to do, maybe do this problem last on a test or a quiz, because it is time consuming, and if you don't get to it, you know, whatever, you don't want to waste too much time on something like this. But if you do find a mistake somewhere in the middle, you can't figure out where you went wrong, just erase it and start over. Sometimes your mind will keep making the same mistake that you made originally and you won't find it. So sometimes it's easier to just say, all right, let me just start over. But let's look at this one and then we'll go on to the shortcut. What am I putting on the outside? What am I putting on the inside? Okay, x minus 8 on the outside and x squared minus 74, correct? Watch, guys, I have x squared. Do I have anything for x to the first power? So I'm just going to write plus 0x minus 74. If you want to make it a minus 0, that's fine. But you have to have a placeholder. If you don't, your problem is wrong because you've got to account for every exponent that's represented in your polynomial. So here we go. First term into first term. X times what gives me x squared? X. Look, I'm going to put it right here above my x column. Get your subtraction ready before you multiply. X times x gives me x squared. X times negative 8 is negative 8x. Everybody with me? Okay, so before we subtract, what do I have to do? Distribute. So change, change, change. What's 0x plus 8x? 8x, good. What happens with x squared and negative x squared? Cancels. And then what do I do with negative 74? Yeah, bring it down. Perfect. And then we're going to do the exact same thing. First term into first term. So x into 8x. X times what gives me 8x? Perfect, plus 8. So get your subtraction set up before you multiply. 8 times x is 8x. 8 times negative 8 is negative 64. But before we subtract, what do? Distribute. So change, change, change. So negative 74 and 64 is negative 10. And my x's cancel, my 8x cancels, right? So what is negative 10? Your remainders, your leftovers. So your answer is x plus 8. And then how do I write my remainder? Minus 10 over x minus 8. Perfect. It's ugly. I know. Some of you saw this last year. Some of you may not have, depending upon which algebra class you were in. So no big deal. You guys are going to be okay. Let's talk about now the shortcut. Okay? We already talked about this, the dividend, the quotient, the divisor, the remainder, all the leftover stuff. You guys already know all that from middle school. What we're going to talk about right now is synthetic division. Anybody seen synthetic division? Okay, if you don't remember it, no big deal. But it's just a shortcut. It's just a shortcut on how to divide polynomials. So I'll explain what this means in a second. So let's just go over here and do some problems, all right? It says use synthetic division to divide. If it just says divide, you can do whatever you want. But if it tells you a way to do it, like use long division, then you got to do that. If it says use synthetic, do that. So the first thing for synthetic division is you set what you're dividing by equal to 0. So I'm going to say x plus 3 equals 0. So what does x equal? Okay, -3. So we're going to put -3 up here in a little box. And that's what we're going to use to divide. Now I'm going to write the coefficients. Coefficients are the numbers in front. I'm going to write the coefficients to all of the terms of my polynomial. So starting with x to the 4th. What is the coefficient of x to the 4th? 1. What is the coefficient of x cubed? Good, very good. There isn't one, 0. What's the coefficient of x squared? -10. The sign goes with it. What about x? -2. And then what about my constant? Is 4. And now we're going to start synthetic division. How do we synthetically divide? The first thing you do is bring down the first term. Always bring down the first term. You're going to multiply to the corner and add down. So I'm going to multiply. 1 times -3 is, I put it right here, -3, and then you're going to add down. What is 0 plus -3? -3, okay? Multiply to the corner. What's -3 times -3? 9. So put it right here. And then I'm going to add down. What's -10 plus 9? -1. Perfect. Now I'm going to multiply to the corner. -1, -3 is 3. And we're going to add down. What's -2 plus 3? 1. Good. Now I'm going to multiply to the corner. What's 1 times -3? -3. And do what? Add down. What's 4 plus -3? 1. Now there's your answer. And you guys are like, what? You just did the long division of this polynomial, but the shortcut way. Here is the coefficients to your answer. If you were to divide x plus 3 into x to the 4, these are the coefficients of your answer. So in our last problem, when we divided like x into the first one, right? So it was like x into x cubed. Your first term started with x squared. It's always 1 less because you're dividing into. So that's how your answer is written. Since we started off with x to the 4th, this is x to the 3rd. This is x squared, this is x, this is the constant, and this is the remainder. Again, the more of these we do, you're going to be like, okay, this is pretty easy. So how do you write your answer? So it's 1x cubed minus 3x squared. Then what? Minus x plus 1. And then what's your remainder? Plus 1 over, what'd you divide by? Well, what did you divide the whole thing? Not synthetically, what did you divide the whole thing by? X plus 3. Your answer always starts with 1 less, because when you take x and divide it into something, it's always going to be 1 less exponent. So the biggest thing to check for, and again, the more of these you do, you're going to be like, okay, this is cool. You just got to make sure there's no gaps, right? Right here, we didn't have an x cubed, so that was good that Freddie was like, oh, you got to put a 0. So let's look at the next one. First of all, whatever you're dividing by, you set equal to 0. So what's going up in the box? 8, okay? So I'm going to put an 8 up here in the box. And then I write out my coefficients. The coefficient of x squared, 1. Coefficient of x, -7. And the constant, -11, all right? Bring down your first term. Multiply to the corner and add down. So it's 1 times 8. 8, and that's what -7 plus 8 is? 1. Perfect. Multiply to the corner. 1 times 8. 8, and -11 and 8 is? Okay. -3, right? So since I started with x squared in my problem, what does my answer start with? X, this is my constant, this is my remainder. So how would you write your answer? Perfect. Once you get the hang of that, it's much easier than the long division. The long division can get really messy. So same thing here. What's going up in the corner? -5. Where'd you get that? Perfect. So you set what you're dividing equal to 0. What you're dividing by, I should say. Okay, so my coefficients of my polynomial. What's the coefficient of y squared? 1. Coefficient of y? 10. Constant? 18. I don't have any gaps or anything. I don't have to account for any missing pieces. So I bring down my first term. Multiply to the corner. What's 1 times -5? -5. Put that right here. So I add down. What's 10 plus -5? 5. Multiply to the corner. 5 times -5? -25. And we add down. What's 18 and -25? -7. Okay. So since I started off with y squared, my answer is going to start with 1 less. So it's what? Perfect. Huh? Yes, you can use this for any problem. The only thing is it works best when your coefficient of what you're dividing by is 1. Because you're using a whole number. When, like that one problem we had 3x plus 2, when you solve it, you end up having a fraction, so you have to do long division. You still can do synthetic with fractions. Just makes it a little harder. There's one question that's going to say divide using long division, just to show. But other than that, do what you want. All right, last thing I want to talk about. This is kind of a vocabulary thing. When you guys see this, using the remainder theorem. Let me explain to you what they want for the answer. When they say, evaluate using the remainder theorem, the only thing they care about is what? The remainder. That's it. They're going to give you a problem. It says, using the remainder theorem, evaluate blah, 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 blah. All that means is, hey, when you divide by this, what is the remainder? That's all that means. You don't have to write the resulting polynomial and all that. So, okay, so here's an example of a question. It says, use the remainder theorem to evaluate, blah, 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 blah. And they even tell you guys, you don't even have to solve anything. They tell you what to use. They say, use the remainder theorem and use -2. So put -2 in the corner. And then write out the coefficients. So what do I write? 3, 8, 5, and -7. Bring down that first term. Multiply to the corner and add down. What's 3 times -2? -6. What's 8 and -6? 2. Perfect. What's 2 times -2? -4. What's 5 and -4? 1. Perfect. 1 times -2? -2. -7 and -2? -9. So the way that you would answer this question is you would say f of -2. When I evaluate using -2, what is my remainder? Just the number. All they want to do is find out what the remainder is. And the reason why, we're going to use this tomorrow, is when the remainder is 0. That means that it divides in nice and pretty. It means it's a factor. Like our first one that we did with the long division, we got a remainder of 0, right? So if you did long division, worked it all out, you got zeros all at the bottom. If you did that same problem using synthetic, you would have gotten a 0 as a remainder, which means, oh, it divides into it nicely. Which we'll explain more about that tomorrow. So let's do the last two, and then we're done. What do I put in the corner? 1, okay? Write out your coefficients. What's the coefficient of k squared? 1. Coefficient of k? -7, and your constant? 10. Bring that first term down, multiply to the corner. What is 1 times 1? 1. -7 and 1 is? Perfect. -6 times 1? -6. 10 and negative 6 is 4. That's the only thing we care about. So you're going to tell me f of 1. You can say k of 1. It doesn't matter. So f of 1 equals, what's the remainder? 4. What that is saying is when I synthetically divide using 1, my leftovers is 4. My remainder is 4. Okay, last one. You can put K, you can put whatever. Doesn't matter. Just I mean, WebAssign, it matters. But for me, as long as you have the function notation, I don't care what letter you use. All right, what's going in the corner? 5. What are my coefficients? Woo, good job. Why is there a 0 there? Because there's no a to the first power. Good. Anytime there's nothing represented for that exponent, you just put a 0. You got to have the placeholder. So, easy part. Bring down the first term. 1 times 5 is 5. 0 plus 5 is 5. 5 times 5 is 25. Negative 28 and 25 is negative 3. So what are they caring about? The remainder. So you say f of 5, a of 5, I don't care, is negative 3. Now, you guys are not going to have a calculator on your quiz or test. We will not make the numbers ginormous where you have to. WebAssign, the numbers might get big, so if you use your phone or whatever just to calculate, not a problem. If you understand the process, that's what I care about. But you're not going to have numbers on your quiz. It's like 5,674 or anything like that. All right, sound good? All right, that's it.